CS687 Capstone AWilkinson, video number 4 of 6 total. Data collection continued. This slide shows run 1, type 1 run, and type 2 runs 2, 3, and 4 for the Qatar dataset. Again, the left-hand side is for the baseline run, all parameters equals 1.0, complete absence of complexity induction theory. Very hard to see, but there is a crossover and a disqualifying crossover for that solution. Type 2 runs 2, 3, and 4 had the shortest path length of the 13 and is considered valid. Data collection continued. Type 3 runs 5 and 6 had a shorter path length than baseline type 1 and is considered valid. And type 4 run 11 again had shorter traverse length than type 1 and is considered valid. Somewhat of a surprise in these results. Data collection continued. Just a magnification to show that the type 2, 3, and 4 runs are different runs. Very similar, different. And type 1 shows it crossover. Data analysis. Same plot, one with points, one without the points. Qatar run 3, the shortest path length. 1,178 merge events required for solution build. Total complexity induction of 1,280 units. Again, somewhere is 10%, 15%, 20% higher. Total delta accumulation plotted and total area under the curve. And one can basically do a quick check on that of an area of a triangle. The plot on the right with points. Too much density to see the characteristic of the curve shown by the ATT48 US cities plot. There wasn't too much experimentation given with the various and really many opportunities to plot. A lot of data gets generated by complexity induction theory. One could introduce a plot that takes advantage of complexity induction for a baseline run, which is the same as number of merge events that's required, and that's a number that doesn't change, the number of merge events required, and the complexity induction for the total for a run with parameters not all equal to 1 unity. It becomes a bit overwhelming the number of ways one can process the generated data. Data analysis continued. Going back a little bit in the slide, 6 nested triangles database, which is an engineered database created, not likely to be naturally found. One can begin to see not sure what to make of that curve. The curve on the right, I think I've actually already shown that, is for the ATT48 data set. Data analysis continued. Playing around with Canada cities. Doesn't really look like Canada on the plot, but the plots, that's okay. 368,497 merges required. Left-hand side most shows the convex hulls with 100 merge events actualized, and that's just impossible to see on that plot. The lower plot shows delta L cumulative of 1,400 units versus 120 or so. Cumulative of complexity induction. Next plot over shows 2,000 merges, and one can start to see that the left-hand side most plot is now getting scrunched up and is becoming non-visible and becoming a continuous curve, apparently. Third from the left plot column is 4,000 runs, and again the delta L cumulative and complexity induction cumulative, and one could start to think that a couple of best fit curves, regression analysis based curves, could become definitive for the curve, replace the curve. And right hand side is for 6,000 merges, and again 2 best fit curves could replace the curve mathematically with minimal loss of exactitude. And doing quick checks of 1/2 base times height on the triangle for the area on the curve relative to the algorithm's calculation shows close enough.